One of the most important properties of sound that we need to be aware of is that its speed is going to depend on the medium on which it's going to travel. It's going to be strongly dependent on that medium. We'll start discussing that by discussing the need for the medium for the sound to travel. Now, as an example of that, I'm going to run a video in a second that's going to show us the need of air for sound to travel. In the video, you are going to see this setting. This is what's called a function generator. It is an electrical generator that's going to generate an electrical signal at a single tone, at a single frequency. We are going to be able to visualize that signal here with what's called an oscilloscope. So the signal is going to have a single frequency, so we see it as just a simple sine wave here. Now this is what's called a bell jar. Inside the bell jar we are going to have a speaker. The speaker is going to be fed by this function generator and is going to produce that single tone. Now, the purpose of the bell jar is to be able to remove the air inside the bell jar. And that's going to be removed through a vacuum pump. This is the hose that's going to the vacuum pump, but we are not going to see the vacuum pump in the video here. There is another opening, there is a faucet of sort, a valve of sort, that the person here can control, can open or close. When it is closed, and when we use the pump, we can pump out the air from here. And then we can let air in by opening the valve. And that's what this gentleman is going to do at some junction. And we have a gauge that's going to read for us the pressure inside the bell jar. The gauge is connected to the bell jar through this hose. You see it is connected somewhere here. And it's going to read the pressure. Initially, as you will see the video, it's going to read for us a value around here. And then when we have low pressure, the needle is going to move closer to here. There is a microphone here. The microphone is going to enable us to hear the sound outside the bell jar. That's what we are going to hear in this demo. Okay, let's get going. What I'm going to do is run first the video without any comments, and then I'll rerun it with comments. Okay, here. Okay, let's run it now with comments. Okay, we are going to start. He's showing the gauge. That's the function generator, the oscilloscope that's going to show us the single tone. You are listening to the single tone now, and you are viewing doing it. He's putting the bell jar, covering the speaker. Look at our gauge reading. It's a high pressure. He closed this valve here, or he's about to close it. He just closed the valve now. And then he's going to start the vacuum. See, the pressure is decreasing inside the bell jar. Notice how the sound amplitude that we hear is getting less and less. The sound that we are feeding in is still the same, but we are hearing less and less. As the pressure drops, we are hearing less of that single tone. Okay, now he's going to let in some air. He did let in a little, so we hear a little. Let in a little more, and we hear a little more. Little more, and we hear even more. More, gives us more sound. Even more. Even more. I hope you get the point here. So, the point from here, we need a medium for sound to travel in. The medium on Earth is air. And the air pressure is going to determine the amplitude of the sound that we hear. It's going to determine as well the speed with which the sound is going to travel. Now, this tells us that in different locations, if air pressure is different, sound is going to travel at different speeds. That's an important point. Another thing that you might think of, if a star, for example, explodes, or something in outer space is going to explode, we should not be able to hear it because sound needs a medium to travel. We might see what's going to happen, but we will not hear it. If there is an explosion, for example, at the surface of the moon, astronauts at the surface of the moon are not going to hear it. They might see it, but they will not hear it. Again, because sound needs a medium to travel.